All right, so today we are taking a look at the second part of lesson 8.8. And when we started this lesson, we started off by talking about what is a linear system. So quick review here, a linear system is two or more equations that have the same variables. And so just even looking at this page right here, this could be called a linear system because it's two equations that have the same variables. They have an x and a y. We talked about how one way that you can solve linear systems is by graphing them, because what we are looking for when we solve a linear system is the ordered pair that is a solution to both equations. So we know that each equation has an infinite amount of solutions, but not everything. We've talked about that with linear equations. And so when we solve the system, we're looking for what ordered pair is a solution to both equations. And so when we graphed it in the first part of this lesson, we were looking for where the two lines intersected, where they crossed, because where they intersected would be the ordered pair that is a solution to both equations, since one line represents all of the solutions to one equation and the other line represents all of the solutions to the other equation. So where the two lines intersect is the solution to both equations. All right, so today we're going to continue to solve linear systems by graphing. We're going to look at two special situations that can happen. Now, just like when we solved equations, these special situations are important to know because they do happen sometimes, but they don't happen all of the time. So actually, most of the problems that we solve today, and even the ones that are in your homework, most of them have just one solution. They intersect at one point. But we need to go over what can sometimes happen when you're solving a linear system. So let's take a look at what is example 2 here. This is nice because both of these equations are already in slope-intercept form. So as we look at equation number 1, we always want to identify the slope and the y-intercept because that's probably the quickest way to graph these. So in this case, the slope is -3 and the y-intercept is 0, -2. So I'm going to put 0, -2 on the graph, and then I can either go down 3 and right 1, or I could go up 3 and left 1. Either way. And I'm going to make my nice line there. And as I move to the second equation, again, I'm going to identify the slope here, which is -3, the y-intercept, which is 0, 3. Put that on the graph, 0, 3, and then again, I can go down 3 and right 1, or I could go up 3 and left 1, and I'll graph that line. All right, now as you look at these two lines, we're looking for the point of intersection, but there's a problem, right? Because these lines never intersect. They're called parallel lines, and so because they never intersect, there is not a solution to this system. So we can say because the graphs are parallel, because the graphs are parallel lines, they do not intersect. And again, we are looking for the point of intersection. So if they never intersect, they have no solution. And when you're doing your homework, all you have to write is no solution. That's your answer. And again, what we can see as we look at these lines is there is no ordered pair that is going to be a solution to both equations because there's no point where these lines intersect. Looking back at the equations, if you remember a little while back, we talked about parallel lines briefly, and we talked about how parallel lines have the same slope. And so we can even see in the equations that these have the same slope there, and so therefore we know that they are going to be parallel. All right, so that was our first special situation. Let's go ahead and take a look at our second special situation. So in this linear system, these are not yet in slope-intercept form. So we're going to need to first move them. So we have 2x plus y equals 4. To get y by itself, I am going to subtract 2x from both sides, which gives me y equals negative 2x plus 4. So my slope is negative 2. My y-intercept is 0, 4. I'm going to put 0, 4 on the graph, and then I can either go down 2 and right 1, or I could go up 2 and left 1 to make that line. Then I'm going to move on to the second equation, which also is unfortunately not in slope-intercept form, so we're going to need to move it a little bit. If it helps you, you can start by doing a keep, change that to a plus negative 3y. I have a negative 6x, so to get rid of it, I'm going to add 6x. So I have negative 3y equals 6x plus negative 12. I went ahead and switched the order there, putting the x term first. You can do that in 2 steps if you need. Then I'm going to divide everything by negative 3, which gives me y equals negative 2x plus 4. Now maybe this looks familiar to you because what you should be noticing is that this is the exact same line. The slope is negative 2. The y-intercept is 0, 4, and so I can graph this again, but it's really just the exact same line that I'm going to be making. It's one line on top of the other. And so, because the graphs have infinitely many points of intersection, the system has infinitely many solutions. Now, we have to be careful. We cannot say that it is all real numbers or all ordered pairs because that's not true. Not every ordered pair is a solution. In fact, as we look at the graph, any of these points that are not on the line would not be solutions. So there's lots of things that aren't solutions, but there are an infinite amount of things that are solutions. And so the way we write our answer is that it is any point on the line y equals, in this case, negative 2x plus 4. And when you're writing your answer in your homework, that's what you need to say. It is any point on the line y equals negative 2x plus 4. Again, it's not any point. It is not every ordered pair. It is just every ordered pair on that line, since the 2 lines intersect, and so therefore 2 lines are exactly the same and therefore intersect everywhere. All right, so these are the 2 special situations. We can either have no solution if the lines are parallel, or we can have that it's any point on a given line if the 2 lines are the exact same and therefore intersect everywhere. All right, so let's practice a couple. Mixed in here, might be some that are no solution, there might be some that are any point on a given line, but there also will be quite a lot that intersected just one point like we practiced in the last lesson, and therefore just have an ordered pair as the solution. So starting with number 5, these are in slope-intercept form, which is nice. So in the first one, the slope is 3, or 3 over 1, and the y-intercept is 0, negative 8. Now, unfortunately, 0, negative 8 is just kind of barely off the graph there, which is fine. We can still go up 1, 2, 3, and to the right 1, 1, 2, 3, right 1, and get enough points on there to make my graph. And again, it's always nice to make plenty of points to make sure that you are getting the line precisely right, so you get that right point of intersection. My second line, the slope is 2, or 2 over 1, and the y-intercept is 0, negative 5. So we'll put 0, negative 5. We go up 2 over 1, up 2 over 1, up 2 over 1. And again, you can see these are kind of hard to tell the exact place of intersection, but if you plot enough points, then you can get those points to intersect exactly. And so the solution here, the point of intersection, is right there. It is the point 3, 1. So again, that pair of system, or that linear system, that pair of equations only has one solution. Why don't you take just a minute and try number 6? All right, so as you finish up, go ahead and take a look at mine. Again, you'll notice this is another one where the two lines do intersect, and so this just has one solution. It is at the point -1, 4, where these two lines intersect. And again, most of the problems that we will encounter will have one solution. Just these special situations happen some of the time. All right, let's take a look at number 7. You'll notice that the first equation is in slope-intercept form. So the slope is -4 and the y-intercept is 0, 1. We'll put 0, 1 on the graph, and then we can go down 4 and left 1, or you could go down 4 and right 1, or up 4 and left 1. The second equation is very close to being in slope-intercept form. If we make that addition and we switch the order, we're in slope-intercept form, and so the slope is -4. The y-intercept is 0, 5. And you might at this point be realizing that these have the same slope, and so we know they're going to be parallel lines. You should still put them on the graph to show the parallel lines that do not intersect. But we can know right from the equation, when we see the same slope, we know that there is no solution. And again, that's what we need to write as our answer, is no solution. These lines will never intersect and therefore never have a solution that is the same to both of them. All right, why don't you try number 8? This is our last problem. All right, so when you move these into slope-intercept form, what you should notice is that both of these equations are the exact same. So you obviously only need one line on your graph because it's the exact same line. You can draw it over the other one, but it should just be one line on your graph because it's the exact same line. And then the solution we say here is any point or any ordered pair on the line, and then you have to give what the line is. And so in this case, that is y equals 2x plus 3. So on your homework tonight, some of them might be no solution. Some of them might be any point on the line, on the given line. Most of them will intersect at one point and have one solution. You just need to be familiar with these special situations because they do happen some of the time. All right, great work today.